Hello and welcome back to this second part of Chapter 12 where we're talking about system development. So for the third question here we have what are the 5 phases of the system development life cycle? And so if you look at those, there are 5 that are listed here. Sometimes you might see 6, might be up to 8, but we'll cover all the different topics that are in each one of these phases, if you will. So as I mentioned previously, the system development life cycle is something that's been developing over a long period of time. People have put different adaptations to that, but typically it follows this same pattern. One alternative to this that adds on to this SDLC is the waterfall method. And the waterfall method says, you start off with the first phase and it falls down to the second phase, so it looks like a waterfall here when you get through all the different phases. The problem with this method is there's no backward integration. And what that means is that once we have the system definition of what we want to do, then we go to the requirements analysis. Well, what happens if this isn't complete, the system definition? And so there needs to be some way you go back to a previous phase and continue there and then go on to the next phase. They call that iterative. And so typically you're going to have some kind of iterative process where you follow these phases, but you would go back and forth between the phases as you needed more information. So how do you come up with the system definition? Typically, you might have a couple of employees that are interested in the project. They would come up and define what the new system should be. They would also assess the feasibility. There's different types of feasibility. There's technical feasibility, there's organizational feasibility, there's economic feasibility, and so on. The technical feasibility we're probably all familiar with in terms of does the technology exist to allow us to do this. The organizational feasibility is do we have the right people in place in order to develop this system? Maybe we have outsourced some of our IT department and we no longer have the programmers there that we once did, and so we can't get that done going that route. Or it may be that we have a different employee set that just doesn't understand how to use the technology, and it may be difficult to implement that technology because of that employee set. So we may have to do something with our employees, may bring in new employees, do some training. Something may have to be done in order to get that definition accomplished or to get the project actually created. And then that group will also look at planning the project. And so, we've talked about different types of committees you might be working on, and so this might be one of those committees. And so the members of those that are going to define this system might include managers, IT, IS professionals, and the actual end users. In terms of the system goals, you also have to set the scope. That is, this system is only going to accomplish this, and it shouldn't accomplish any more. It should interact with other types of systems or not interact with other types of systems. Who's going to be involved? What different things can they do, and so on. So if you don't set your goals and your scope at this point, then you open yourself up to have a lot of scope creep in terms of your project, and that leads to over budgeting. And so the example that your book uses is that example with that little opening vignette. Think about these in terms of how will that Xbox application contribute to more ad revenue? Will it enable Pride systems to earn more from current clients? Will it attract new clients? So on. So these are all things that you would need to ask yourself during the system definition. Because, that economic feasibility is probably one of the big things that you want to look at. If the costs don't outweigh the benefits, then you're not going to continue on with that project, or it'd be a waste of money. So graphically, this is what it might look like in terms of your system. Notice there's one more feasibility there that I haven't spoken about, and that's schedule feasibility. Can you go ahead and create this system given all the other things that you have to take care of in your organization with IT? They may not have the time in order to do it. It may be just too lengthy, and then it may be too costly to hire out in order to get that done. And so once you have your team made, you want to make sure that you have a diverse set of people on your team so that you're not just getting one view of what that system should be. We've talked about having a business analyst. That's someone who specializes in understanding the business needs, the strategies and goals, and helping the business make sure the system, once it's implemented, it'll accomplish the strategies they want. And then a systems analyst of some type, which is an IT professional who understands both business and technology. Once you decide you're going to do the project, then the next phase would be the requirements definition. Then once you have all that specified out, you go into design and implementation. And this is where you turn it over to more IT specific type people. They're going to be the ones that are writing the software, they're testing it, making sure it works with the databases, make sure it works with other systems if that's how you've got it. Okay. Notice this last point here is that users must be actively involved and take ownership of the development project. And what that means is that research and my own personal experience has found that if you don't involve users in the entire development process, then they're going to be less likely to accept the system once it gets delivered. And if they don't accept the system, they're less likely to use it. You, as a manager who may have approved the funds for doing this, will have misspent the funds because now the system won't be used, and upper management will see this as a failure. So make sure that the people who are actually going to use the system are involved in that development process. They're using the prototype, they're giving feedback to the programmers and IT folks who are developing it so that it does exactly what they need it to do, and make sure that it's still meeting the goals of what you initially approved the project for. So is it still within scope? Is it meeting the definition, and so on? So one way to get the requirements analysis, you could look at existing documents, forms that people use. Maybe you just want to automate how people buy a product. Instead of filling out a form at the cash register, now you want to do this automatically so you can watch how it's actually done. But you could look at existing forms and maybe you want to just automate that, put that into a form so a database can now be used, and that automatically captures the data and puts it into the database. You also need to think about the security of your system. Who can use the system? When can they use the system? Where can they use the system? And so on. All right, we talked about creating a data model. That's done in this phase as well. The data model is going to look a whole lot like your relationship model that you've seen inside your relational databases. And think about all of the different components of a system. That is the hardware, the software, the data, the people, and the procedures. And how that's going to be impacted, and what are they going to be doing now with this new system. Is it going to change the way they used to do things? Is it going to improve things? Hopefully it's going to make some kind of improvement so that its benefits outweigh the costs. So during this requirements phase, we're also going to be then looking at some specifications. So you may have to go out and get some bids, some requests for proposals, so on. So you're looking at hardware specifications, any software specifications, also, what kind of database you're going to use. What are you going to do in terms of having some different procedures in place in terms of how does it normally work? How do you back up your data, back up the system, back up to remote locations? What do you do if some kind of disaster happens and you need to recover? How soon can you do that? Those sort of things. And then you might have job descriptions of everybody that interacts with that system. And that also includes their security areas, what they can get into, what they cannot get into, what they can change, add, modify, delete, those sort of things. So once the requirements are approved, we move on to the implementation phase. But keep in mind that, as we do these approved user requirements, then we're going to be doing the component design. And what that leads to is the design of the hardware and then also the design of the database. So once we have the data model, which I like to call the logical model, then we go to a physical database design. And so, if you were taking a database course, you'd be more familiar with what that process is and what things have to be changed. But just, keep in mind the terminology so you'll understand when it happens. So then we go to, once we have that done, we can think about the requirements that have been approved by the user. And we can start thinking about the software that's going to need to be designed too. Now, in terms of what we think about as software, are you going to buy something off the shelf? Are you going to, and that'll work great for you? I mean, it's already pre-designed, built and everything. Or you're going to have to buy software and then change some things around to meet the way things are done in your company, or you're going to develop it from scratch. Typically, not a lot of things are developed from scratch anymore. A lot of times people will buy pre-configured software for their industry or their type of business, and then they'll modify it to meet their processing needs or what their terminology that they use inside of their company. Some other things that you need to consider, though, when you're thinking about this software component: will it work for the devices that you have in your company? Is it going to work in the cloud? Can I move it to the cloud? Is there something different that I have to use because I want to use the cloud? Those sort of decisions also need to be made. They probably should have been made earlier on when you were doing your feasibility analysis of whether you wanted to go on or not, and also the technology analysis of whether you wanted to go on or not. Then we've got this thin client or native application. Again, you're going to run it on some other device, something small. Is it just a terminal, or is it going to be a whole desktop that I need to have? Is processing going to be done on that desktop or on that other device, or is all processing going to be done on a server? And that gets into some network usage of how you want to send your data back and forth, and also your processing back and forth. And so there's whole classes on that kind of terminology, that kind of discussion. But again, just be aware that that's what has to occur in terms of the software design phase. We've talked about that database design. When we convert it, we're going to use different techniques that that were described in Chapter 5. So you may want to go back and review that if you're having some problems understanding what the logical design to physical design type of creation in a database has to take place. Again, you can buy off-the-shelf software that has a back-end database that's already built in. This is what CIS does, and they use Oracle as their back-end, which is the reason why it's such an expensive piece of software. So CIS actually has developed different modules for different types of industries, and so you can buy those modules as you need them and implement them, and then they come in and configure them to whatever your needs are. Then, if you remember from that previous slide, a couple of slides ago, we were talking about the procedure design. What do we mean by normal processing, backup, and failure and recovery? Normal processing might be is how do people start different procedures, how do you stop certain things, what kind of operating system is it going to use, backup, you should understand what that is. Also, the failure and recovery. If a disaster happens, how do you get back up and running? All too often, people don't realize that if you go down, then you have probably less than 2 days to get back up and running, or your business typically will go out. And that's what they've found for the last 20 or 30 years. So make sure you have a way and you've tested to make sure that you can recover and that you have some kind of off-site storage and backup. You also need to think about your job descriptions with this new system. The systems analyst will be the person who will help you with that. You may also have to create some new jobs with the new system. Right? So when you do that, you're going to have to specify the duties and responsibilities. Make sure that people have those skills that are needed in order to interact with this system. Right? And so that those new skills will be added to whatever existing job skills they had. So you want to make sure you hire the right people if you're going to have to go outside the company for that. The next phase is the implementation phase. And so during this phase, you're building the system, you're conducting the tests, and you conduct integrated tests, which means you're looking at having it integrated with different systems, different types of users that are using the system all at the same time, and then you're converting to the new system. Right? So when we talk about system testing, we're talking about you typically will have a test plan. You'll have some kind of quality assurance. Some people will have different test cases or test scenarios that they'll use for your system. So you'll enter some data and see if it produces the right reports. You'll enter some error type data and see if it gets caught to make sure you don't capture bad data and so on. And so once you get past the alpha testing, you go into beta testing, and then if that passes, then that's when you can say, okay, I'm ready for this system to go into production. That is, you're ready to convert over from the old system to the new system. Right? When we convert over to a new system, there are 4 different ways you can do this. One is a pilot system, and that's where you implement the entire system in a small area of your business. The example I like to use is, like, let's say you own a bank and you have a bunch of different branches. So you've just created this new system, then why not start the new system in one of your branch locations and have it run for a while to get the bugs worked out, so to speak. And then once that's working, then you just make a copy and send it out to all the other branch locations. Now you can also have a phased approach, and in the phased approach you only use certain modules of your system, and you use those until you know they're working properly, and then you add more modules until the entire system has been installed. There's also a parallel approach where you run both systems, that is your old system and your new system, at the same time to make sure everything's working properly. And as you can see here, this is the safest way to do it, but it's also the most expensive, because now you've got to hire people to be putting data into the new system and the old system at the same time. You're running those systems. The cost of running and maintaining is all there. But if something goes wrong with that new system, it's not working right, you got the old system to fall back on. Now the last type of conversion is called the plunge, and it's the most expensive, or not expensive, but the most risky and the least expensive. And that means with the plunge approach, you're going to say on a certain date we're converting over to the new system. So everybody has to get that new system up and ready and make sure it's tested, ready to go. You finally do the plunge. You cut off the old system. There's no way of going back. And so things had better work, or you're going to be in a lot of deep trouble in terms of, okay, if that didn't work, now we got to go back to a manual way of doing things, or you got to try and recover somehow. And so that can be very risky. But you might use the plunge system if you're going from a manual system to an all electronic way of doing things, or a system that's never worked before. You know, if you're sending somebody to the moon, you know, everybody needs to be up and ready to go by a certain date, and everything needs to be working flawlessly. That's a plunge type system. So on this particular slide, we're looking at a summary of the different tasks for the 5 IS components. And so I've been talking about all of those. So you've got the design phase, implementation phase, what has to take place for each of those components. Another way of thinking about this system development life cycle, if you will. The last phase is the systems maintenance, right? So we've implemented this system, everything's working good. Now we want to maintain this system. So what takes place during this? So in this phase, we're looking at, you know, recording requests for change. What kind of problems have we had? What kind of changes or upgrades do we want? Then we need to prioritize those upgrade requests and also those failures. You know, if there's a problem, let's say somebody doesn't like a color on a certain screen and they've logged that in as a failure or a problem they want fixed, how quickly should we get to fixing that over a problem that does an incorrect calculation somewhere? So you see the dilemma. You would fix the incorrect calculation before you'd spend much time fixing just how things look. And so you also, with this maintenance, you got patches that have to be fixed or implemented every so often. If you're looking at operating systems come out with service packs, which is typically all your patches rolled into one. What happens if the operating system comes out with a new release? Do you upgrade? How does that impact your system? And sometimes that can break a system where they don't work at all. So you need to be careful about running those patches, running the service packs, or running new releases, because that can all have an effect on an existing system where whatever changes that were made in that software now impacts your entire system, and it may not work anymore or give you incorrect results. So you've got to check and debug all of that. So question 9 is, okay, what are some problems with the system development life cycle? Right. So with that system development lifecycle waterfall approach, getting the requirements documentation can be difficult. The analysis paralysis might take place. That's where you spend too much time on the documentation and not enough time on doing things. And so because you're trying to document everything, it can take years to develop a system and get it going. There are also some scheduling and budgeting difficulties, especially if it's a large project that may be even 2 to 5 years before it gets implemented. During that 2 to 5 years, you might have people quit the company or get hired by the company. They've got to be brought up to speed then on how this project's working and so on, and that can even slow the project down some more. And so hopefully, if you've listened to this chapter, you have some idea of the system development life cycle, the process of going through and developing a system, how it relates to the 5 components, what are the different phases of the SDLC model, and what takes place in each phase. And so that ends this chapter.